All right, guys, we are going to look into doing some real life problems here with volume and how we do. So, an ice cream cone has a height of 12 centimeters, a slant height of 12.65, and a radius of 4. If you fill the cone completely with ice cream, how much ice cream can it hold? Also, if you want to coat the entire cone, excluding the top opening, with chocolate, what's the surface area? So this will come up a little later on, but it's good for us to talk about right now. So first of all, we need to know we're talking about a cone. And if we wanted to fill the whole thing, if you wanted to fill that cone all the way up, completely up. You want to fill it all the way up. That's a volume problem. Okay. So that means we're going to use 1/3 pi r squared h. Here's our height. There's our h. Slant height, that's going to show up for surface area. And the radius of 4, so that's our r. So we're going to have 1/3 pi 4 squared times, and this time we want to use 12. Okay, so 1/3 pi times 12. Let me see, where's my... Oh, go back on that. There we go. 1/3 times pi times 4 squared times 12. That gives me 201.06. And this would have been centimeters. Whoops. Start drawing M there. That's not very good. Centimeters cubed. So about 201 cubic centimeters is how much ice cream it will hold. Okay. Depending upon if you're already into scale 9 or not, how do we find surface area of a cone? Well, that's a different thing, and we don't have to do that, actually. Never mind. You do not have to find the surface area of cones this year. That's not part of our standard. We're only finding the surface area of pyramids. So we don't have to do that last part. So I'm going to tell you to disregard this last sentence. You don't have to do that part. Sorry I put that on there. You don't have to do that. How can I advance my screen like that? There we go. So a spherical water tower has a diameter of 20 meters. Spherical water tower. So we're going to be looking at a sphere, right? So that's what, 4/3? So that's 4/3 pi r cubed. Then it has a diameter of 20. So remember, we got to find the radius. So since this was a diameter, we're going to take 20 divided by 2 to get 10 for the radius, okay? So we'll go back and we'll type in 4/3 pi, and we're going to use 10 to the third. So 4/3 pi, and then we're going to do times 10 to the third power. That will hold 4,188.79 cubic meters. So you can put m to the 3, or if you ever want to know, you can call it cubic and then type in cubic meters. You do not have to give me the units. All I want from you are these numbers to the nearest hundredth. Okay. If it can go to the 100th, go to the 100th. If it only goes to the 10th, give it to the 10th. If it only gives you a whole number, give it a whole number. So that's how many cubic meters it can hold. Okay. What else do we have here? We got a company company is designing glass pyramids for the top of a building. The base is a square with side lengths of 15. Slant height of each triangular face is 13. How much glass material is needed to cover the entire pyramid? This would be a surface area problem. Okay, that's a surface area problem, not a volume. Okay, so to find the surface area, basically you just want to find the area of each surface. So a company is designing glass pyramids for the top of a building. The base is this, slant height is this, how much glass material is needed for the entire pyramid, all of it. That's what I was looking for. All of it. So the bottom and the top of it. Okay, bottom and top. So we want to find the area of all, since it's a square pyramid, it's got 4 triangles around it and a base, so all 5 sides. So the base of this thing is a square with side lengths of 15, so I'm going to take 15 and squared and get 225. Then I have some triangles, and we're told that this slant height, that's this part right here, that's 13. We were already told these are 15. So this is 1/2 base times height, or 1/2 13 times 15. So what is 0.5 times 13 times 15? We're going to get 97.5. However, on a pyramid that's a square base, so think a square has 4 sides, you're going to have 4 triangles. So we got to do 4 times this 97.5. So times 4, because I still had it in there. So that turns out to be a whole number of 390. Then I want to take this number and add it to this number. So 390. Whoa, what just happened? 390 plus 225 gives me my final answer. How much glass is it going to be? 615 cubic meters. So you would tell me this is 615. That's in PA 9. Did I give you another one? Construction site has a pile of sand in the shape of a cone with a height of 3 meters and a base radius of 2 meters. How much sand is in the pile? This is a volume problem. How much sand is in it? This would be a volume problem. Okay, so the volume of this would be, since it's a cone, 1/3 pi r squared h. We're told the radius is 2. We're told the height is 3. So 1/3 pi 2 squared times 3. So this turns out to be 4 pi. That's in terms of pi. If you have that on my calculator, remember there is a button on my calculator that looks like this. Push that button and you will get the answer of 12.566. So we would say that's 12.57. And that would be cubic meters. Okay, cubic meters. So if you think of a yardstick, meter is longer than a yardstick. So you're going to have a yardstick this way, a yardstick back, and a yardstick up. So it's quite large. If you think of a cube, the way I've always drawn a cube before was like this. But all those are 1 cubic meter. It's very big. All right, what's last? I think it's our last one here. It says a monument is being designed in the shape of a pyramid with a square base and a height of this. What's the volume of the monument? Straightforward, right? Volume of a square pyramid, remember, is 1/3 base times height. That's the volume of a pyramid. Our base this time is a square. This is our base. So remember, that's the side length squared, not 5, but the side length. So I should write that out for that, side length squared. So I'm going to take 10 squared, and in my height of 18, so 10 squared is 100. 1/3 of 18 is 6. So this should be 600 cubic meters. That's bigger than the sand we just had, isn't it? So let's see. 1/3. Let's see how good my math skills are. 10 squared times 18. 600 cubic meters. This is what you would type in. Oh, I have one more. Okay. I wonder how many of these I got. It says a gym orders basketballs with a radius of 12 centimeters. The gym receives a shipment of 30 basketballs. What's the total volume of the basketballs in the shipment? So we need to find the volume of one basketball. One ball, since its volume is 4/3 pi r cubed. So 4/3 pi, and our radius is 12 cubed. So what's one of our balls? 4/3 pi times 12 cubed. So one basketball's volume is 7,238.229. So we're going to call that 7,038.23. That's only one of the balls. Remember, I had 30 basketballs that I ordered. So I'm going to take 30 times that number. Right there. So 30 times 7,238.23. And I'm going to end up with a volume of 217,146.9 cubic centimeters. That's your answer to that one. That's all of them.